Okay, Assalamualaikum warahmatullahi wabarakatuh. Today we're going to continue our tutorial session with tutorial number 5. Okay, inshallah, let's begin now. Okay, first of all, you will, as usual, inside the Google Classroom, you will find the 2D stationary groin folder. So inside the folder, there will be 4 files. Number one is the hard layer dot text and the parameters dot text. And you have the run model batch file. And last, the bat level dot text file. Okay, as you can see from the name of the file, the folder file, it's called stationary groin. So today we're going to do two-dimensional stationary groin. There will be two exercises inside the XBeach tutorial 5. So this will be the part 1. Part 1, we're going to do the example 2.1, and then we'll continue with the part 2 is on the Yanchip perch, beach and natural breakwater. Both are two-dimensional. Okay, so what is the first one, the 2.1? This example shows you how to set up two-dimensional morphology model. We will see beach evolution due to a presence of perpendicular structure, headland or groin. Okay, accretion and erosion near the groin can be observed. So that is the point of today's tutorial. We just want to see if there's a groin here, what will happen, accretion or erosion. And basically, if you look at here, we're going to do a stationary wave model. In XBeach, there are three options, hydrodynamic options. The first one is stationary, the second one is surf beat, the third one is in the non-hydrostatic mode. So today we're going to do two-dimensional stationary wave model with where it's efficiently solve the wave average equation but neglecting the infragravity wave. This is for the 2.1 part 1. So as I have to remind you again, make sure you copy the folder where you can read the software, because if you right click the run batch, open it with the X notepad++, you can see here in my call domain, I read the xbeach.exe in my XBeach GCEC folder. So you have to make sure that you have the correct path to read your exit this exe file, the compile where it compile or the XBeach coding. Okay, so if you cannot run it, meaning that you haven't succeeded in calling your xbeach.exe, the execution file. Okay, make sure that you have the correct path to do that. Okay. Okay, next to do is, so moving on to our first case. Here is our domain. You can see here is the part, the groin part, the groin, and it's split in the middle is a 4,000 meter on the y-axis and 1,000 meter on the x-axis, and the red color indicates the bed level, where it's high on the red and also deep and getting deeper for the blue side, for the blue colors. Okay, so there are two YouTube showing you exactly on what will happen if there's a headland and groin. So you can watch these two videos. I'm not going to run it here because it will take some time to. So if you have time, you can watch these two videos just to get an idea on how this perpendicular structure will work and how it will influence the accretion and erosion near the groin. Okay, so number one, inspect your depth and grid file, how the initial profile looks like. Plot the profile using Excel. Okay, so in order to understand what is your depth and also grid file, you go to the params.txt and you edit with notepad plus plus. Okay, so this is the parameters.txt file. You can see all the processes, flow boundary condition, numeric parameter, everything is in order based on what parameter they belong to. Okay, and because we want to look at the grid parameters, so this is the part where we have to analyze, look at. So the grid form is XBeach, and see here is depth file is zb.txt, meaning that in this case, the modeler doesn't use the RF grid to create the grid. He used a text file, meaning that he create the file using Excel, export it in the text file. So the depth file uh, can also be created using Excel and also text file. So the thing that we need to look at is this part, depth file equal to zb.txt. So you can go back to the folder. So this is the zb.txt, which is the depth file. Okay, so we want to look inside the text file. How are we going to do that? We open our Excel. Okay, one thing to remember, I need you guys to open everything first before you do this tutorial. Make sure you have your RF grid, quick plot, not pad plus plus. Okay, when you have everything ready, then you can start doing the tutorial. Okay, moving on, I open the Excel file, file, open. Because I already opened it yesterday, I'm going to click on the zb.txt. Okay, so when this thing will pop out, you choose the delimited, meaning that you want to separate using space or tabs, and you click next. So you click on the space, so it will assume the space as as the thing that can separate your data, and then next, and you can click finish. Okay, so this is your zb.txt. So this Excel file here, everything up until 401, this is the one that create your bathymetry file. Okay, if you look at those number, everything look quite similar. So in order for you to understand, I control everything and I change to general. So you will not look so confusing with the scientific number. So you can see all have similar depth. Okay, this is the depth from 13.6 meter from the first line. And look all the way the right hand side, it's slowly decreasing up until minus 4.53. So this one shows you the depth. So this all the cross show. And then this another point, another point, another point, another point. Okay. So if you don't believe me, you can just Control Shift and then highlight everything. You can plot using one 2D line. So you can see here. This is the cross shore profile. Slowly getting deep. Okay, it's depth 5. Okay. Now all this represent this area. This area. Line here, one line, three line here, cross shore line. So in the middle, there's a groin. The reason why they want you to inspect your depth and grid file, because they want you to check where is the groin and where is it located. Okay, so because it's in the middle, try to find the middle of this file. Okay, for example, this is a 401. It should be here is 401, so the middle should be around 200 here, 200 here. And if you look at the right hand side, here it suddenly have uh, here. Oh, sorry, you maybe not going to see clearly. Change the color, change it to yellow. Okay, you can see here only these two lines have a different value in the middle. -8, -8, -8, -8, -8, because this is the part where the groin is. Okay, try to plot this one. Okay, so you can see here is different. So maybe you cannot compare it. Try to plot this the file before this groin line, just to compare. You add another values. You choose a line before that line, center. Okay, so you can see clearly. Okay, so this is the line before the groin, and this is the line where the groin is. In the middle, there are two lines represent the groin. Okay, I hope you can understand that. So some of you might wonder why exactly the groin is upside down here, and the groin is here. Okay, so there's a reason for this. I want you to go back to the params. Okay, you can see here params here, the post down equal to 1. You google not google you go back to your XBeach manual, post down, type post down. Okay, here you can see, make it a bit bigger. The value are positive down by default. Example, value of 10 is 10 meters depth, but this can be changed using position down keyword, meaning the position down here equal to 1, meaning that position downward is positive. Here 40 meter or 30 meter, meaning that the XBeach will accept it as 13-meter depth. Okay, 13-meter depth. Okay, to write it for you. Okay, mm, here. So position down equal to 1, meaning that XBeach take this 40-meter, the one that positive, as the depth. That is why it looks like it's upside down, where 40 meter here or 30 meter means 40 meter depth because it's the position it took, the downward side is positive, but in reality it's like this. Similarly, the value are positive down by default, so here is positive down, as which read the 14 as depth, and minus 5 here, minus 5 ni as 5 meter beyond mean sea level. But in reality 14 means here from the mean sea level. Because why? Because sometimes the most important file to read is the depth file rather than the one above the mean sea level. So that is why, to make it not confusing, the modeler choose to assume everything that below the depth, below the mean sea level is being assumed as positive to make things easier. Because if you want to handle a case where you only want to do you to focus on the depth file, you don't want to start with negative, negative, negative. It will be make things complicated. So everything that's starting from zero and below the mean sea level, you accept it as positive because you only concern everything that happened below the mean sea level. That's why the text file here, it do like this, because it know the XBeach file will accept the zb.txt, and the XBeach will read this one as a depth file, because we already told XBeach that this positive value is the depth file and the negative mean is above the mean sea level. In reality, it should be like this, but when reading, it put like this because it wants to help the XBeach to make things simpler. Mean positive is uh, that file. Okay, so I hope you guys understand that. And then the next question, check what is the height of the groin and where is it located. So I already told you that the depth of the water you can just estimate here. And you know where the groin located. Of course, in the middle, you have 4,000 meters along the y-axis. You can divide it by 2 and then you can find where the groin is located. The difference also you can estimate from the height. Okay, and now check your hard layer file. What are the values used for the groin structure? Going back to your folder, this is the hard layer dot text. And what exactly this file means? If you want to know what it actually indicate, represent, always go back to your params. Looks for the hard layer. So this hard layer dot text equal to ne underscore layer. So what does this means? If you want to know more, then you should go to your XBeach manual and then type ne underscore layer and look for it until you find, okay, it's under 6.2.0 morphology. The struct and ne underscore layer keywords enable the user to specify non-erodible structure in the model. To switch on non-erodible structure, use struct equal to 1. Dia tak apa. Paling penting sekali yang ni. The values of the file define the thickness of the erodible layer on top of the non-erodible layer. An E layer file with only zeros therefore define a fully non-erodible bathymetry. File with only tens mean an erodible layer of 10 meters. Okay. So we want to look into the hard layer.txt. You can open again the hard layer file using Excel, open the hard layer, text. Again, you use space to delimiter your data content, and then to separate it, finish. Okay, and some of you guys might get confused with all this scientific number. Control A, all, you can change to general. So here you can see all 10, 10, 10, 10. What does it mean? 10 here. 10, 10, 10, 10, 10, 10, 10, 10, 10, 10. What's the manual say? Say that a file with only tens mean an erodible layer of 10 meters. So this all meaning that it allows the area to be eroded by 10 meters. But wait, you say that there's a groin in the middle, right? So try to look at the middle. 200. See here, you may notice something. It's zero in the middle. So what does zero mean? An NE layer file with only zero define a fully non-erodible bathymetry. So what does that supposed to have a significant connection with your bathymetry file? Can someone, uh, can you figure it out? Meaning that this area, everything can be eroded based on the bathymetry. The bathymetry can be eroded. It depends on your sedimentation. But only this area is non-erodable because you put zero here. Meaning what happened, that this structure cannot be eroded. So that is how do you build a non-erodable layers. For example, you just not just groin, you want to put structure here, building, you put resort and everything. So you have to define it as non-erodable structure of not, or else everything will be swiped together with the wave and sedimentation. Sedimentation, the accretion or deposition will not happen because this one also going to be pushed away by the wave. So we have to make sure this part is non-erodable. Anything happen pun dia stick macam tu je. Sebab dia keras. Dia hard structure. That is the reason why dia letak zero kat sini. So XBeach will understand that this part zero here is non-erodable. The rest is erodable by 10 layer of 10 meter. Okay. So that one answer your question for number 3. Check your heart. Okay. What are the values used for the groin structure? So I think you can answer this one as well. Okay, next question, number 4. Check the parameter file. What are the grid sizes? What is the size of the model domain? What is the initial water level? Why position down is now set to 1? And what does it mean? What is the wave height, wave direction, wave period? Is the wave being stationary or instationary? What is the T-stop and what does it mean? What is the grain size? When the morphology will start? So I believe everything here you already know. You can have a look inside the parameter. Everything is there. You can answer it. Direction. Okay, the things that I want uh, just want to say here is that on this wave direction, because of here, you look at the parameters. Parameters on the here grid parameters. You can see the Alpha is 0, theta mean is 190, theta max 350, d theta is 20, theta naught is 1. So make sure you explain to this what makes it important to have this one. Where is the x original and y original of the simulation, and how does it relate to this part? This part. Where is the theta mean? Where is the theta max? What is the alpha? What is the d theta? And here you can see here the direction of angle or main angle. What is this one means? Okay, one thing for sure is that the stationary one, okay, the stationary one only have the direction here of the wave, doesn't have the main angle, because the main angle here, if you recall the last session, you have a lot of wave group. That's why you use John swap dot text. But because of this stationary, you only have one wave je, tak ada wave group. So you don't have any John swap ke dot text ke. You only have one type of wave energy coming in. And that is the reason why you look at the wave boundary condition, dia terus directly bagi you instead taper, wave height, TM, direction 0 meter, because ini adalah untuk stationary. So kalau you look back on your XBeach manual, you type taper, on this 4.4.2.1, you can see stationary wave boundary condition. In stationary mode, only the relevant data from the file is used, and irrelevant data like gamma and are discarded. Because in stationary wave boundary condition, only yang ni je yang penting. Dia tak ada banyak wave spectrum. Itu direct je, satu saja. So sepanjang that time, they only use one type of wave group energy. So because you do a stationary, you tak buat stationary. Macam last week you do order 1D tapi dia ada wave group juga. But that is why the reason dia panggil banyak wave spectrum from John Swart. So this one thing that you have to reconsider. And you can see the direction, mean wave direction for stationary dalam nautical convention. And you go to the parameter.text, it 240 degree. So 240 degree, looking back at your sketch ni, 240 degree belah mana? From nautical, this red line. Nautical 200, 180, lebih kurang. Sini juga. Kan ni masuk. Sini juga. So meaning that from your file here, kat mana 0 point dia? X ori, Y ori. Nanti you boleh, bila you run quick plot, then you will know where is X ori and Y ori, and then you will tahu kat mana arah wave coming in. This way ke? This way ke? This way ke? Okay. I guess that answer your question. And then number 5, double click on run model. The model running time is 20 minutes. So you can go back to the folder and you can run the model.batch. And then what is the name of will be on the XBeach output.nc. Go back to the parameter.text. You can see here, net CDF file name, the output. Here is the output file. So when it's finished running, you will have this XBeach output D50 to 150 micrometer 365. Tak apalah, this is just the name, you can just change the name. And you have the X block as well and XB warning. So everything is written in the X block. If it is default, everything will be in the X block. It will tell you what is the default value used in your simulation. Okay. And then number 6, this one finish. Open quick plot and check the result. Any morphological changes observed. Okay, you can open your quick plot. Okay, this is the type of the output that uh, you wanted, because in the parameter you can see output variables. This is all the output that you want, so you can put it here. If you don't understand it, you can just go back to the XBeach manual. So you have bed level, water level, GLM velocity in cell center, wave height based on instantaneous wave energy, cumulative sedimentation, erosion, wave force. And you have 25 of time step. Why do you have this 25? You have to explain as well in your report. Why the time step is 25? How long is the hydrodynamic or morphological time in this study? How many seconds? How many days? And at what time interval do you save your file? And that's determine the time step. This T interval ni 36,000 second. Mana every 36,000 second dia save as one time step. So macam mana boleh keluar 25 ni? Macam itulah the point is. And you can see how the sediment erosion happen. Can quick animate. And you can see where exactly here is the X original and Y original. Where is it? Here. The X original and Y original. So where does the wave coming in from? So from that you can estimate on how the sediment accretion happen, where the accretion will happen, where the erosion might happen. Does it similar with your hypothesis? Okay, this is the hard layer. Okay, you can also see the bed level changing. Bed level changing. How the bed level? Is it increasing the bed level morphological or it's decreasing? So you can observe here. Try to connect it with the wave energy as well. So you have the wave energy, wave force. Okay, try to play around and to see how it connected. So the more you try to make a common sense conclusion, so the more mark I will give you based on your observation, because the data, everything is given to you. So you as a student, as a consultant, you need to make sense everything, the data that you have, in order for you to give suggestion or solution to other people. You can try to play with the magnitude, the vector. See here the vector. So if you cannot see clearly, you can just change. Either you want to use rooted error, center error, rooted line, different colors vector. Okay, you can try different things. Try to observe. Okay, I think that is all for the tutorial 2.1. The end of part 1. Just write a short conclusion on what do you understand from 2.1. I think that's all for now. You're going to continue part 2. Thank you very much.